All right, so we talked yesterday about length and how we measure length. We're going to now combine that a little bit with area. And really area is, so length is a one-dimensional measurement. Okay? We're measuring in one single direction. Area is a two-dimensional measurement because you need to measure multiple lengths. So we have some formulas we use, and I'm sure you know this. The formula to calculate the area of a rectangle is what? See it? Length times width, yes. Area equals length times width. How about a circle? How do we calculate the area of a circle? Holly?
Diameter times diameter.
No? Dean?
Diameter times pi?
No, that's circumference. Area of a circle is pi times radius squared. You guys know pi? Apple, cherry, pumpkin. What is pi equal to? 3.141592. I don't remember. Some people memorize all of them. You can use 3.14. That's fine. You can also use the pi button on your calculator when you're calculating area. It will whether if you use 3.14 versus using the pi button on your calculator, you will get slightly different answers because the pi button on your calculator has more decimal places than just 3.14. So it's up to you. You also need your calculator. Did I tell you you need a calculator for this unit every day? You will. All right, so pi times the radius of the circle squared. What does squared mean? Okay. Not times 2. Times itself. And then circumference of a circle, the length around the outside of a circle. The formula for that is pi times diameter. The diameter is the distance across the circle through the middle.
What's the radius?
Half of the diameter, from the midpoint to an edge. Now, this next part is very important because on the labs that we do over the next couple weeks, I'm going to always ask you when calculating area or volume or density, I'm going to say to show your work. I want to be very clear what that means because lots of times people don't do this and they lose points. Like I told you at the beginning of this unit, often students struggle a little bit with this unit. And often it's because they're not following instructions properly. Okay, so when on a lab, like we're going to be doing today, you're asked to show your work. I don't need to see your math work. I don't need to see your long division or multiplication. But what I want to see is a few things. First, you write the formula that you're using. Second, you write the formula again, but this time you substitute numbers in for the variables. Third, you calculate your final answer. And fourth, you must have a unit on every number that you have. Always use a unit. So that's what I mean when we say show your work. So formula, substitution, answer, units. 4 things you need when I say show your work. All right, so let's look at a couple examples of calculating area. So we have here a rectangle. Go ahead, calculate the area of this rectangle. Show your work, please. Okay, Lena, what do I need first?
You take the length.
Okay, but what is my, so what are my steps when I say show your work? First you need
The 2 numbers.
what? No, before that I need, Gage,
We're doing the formula?
the formula. Area equals length times width. How do we indicate times when we're writing a formula like this? What are some things you can do? Actually 3 different things, or 4 different things. See them? Yeah, sometimes that's confusing because x could be like a variable or something, but you kind of need to write LXW. What else can you do, Lena? You could put a little dot. That means times. What else can you do, Jake?
You can put them right next to each other.
Just put them next to each other, yes. Or, last thing, Gage?
Put it in parentheses.
In parentheses. They all mean multiply when we're writing out formulas. Okay, good. Second step, Lena.
Put in the 2 numbers for like the width.
Yes, substitute your numbers. So you met the length we're giving you is what?
4 seconds.
What's that?
3.6 seconds.
3.6 centimeters. Remember, length is the longest. What is the width? Lena?
4 centimeters.
4? No? Gage, what's the width?
0.4 centimeters.
Yes. 3.6 centimeters times 4 centimeters. 0.4 centimeters. What's my third step? Gabby? Yep, and what is it? Okay, 1.44. Let's talk units. What are the proper units for area? Anybody know? What?
Square.
Getting there. Square.
Square. Square.
So it's 1.44 square,
Centimeter square.
centimeter squared. What you do to the numbers, you also need to do to the units. So we multiplied 3.6 times 0.4. What did we get when we multiply centimeters times centimeters? Centimeters squared. 1.44 centimeters squared.
I don't really think that makes a bunch of sense to me.
What?
I mean, the fact is, like, it's 3.6 centimeters long, and then it's 0.4 centimeters tall.
Because it's not like 3 times
Yeah.
1. It's like, it's not 3 times 1. Like if it was 3 times 1, then it'd be like 3. So since it's not like 3 times 1, it's going to be less than 3.
Because 0.4.
Yeah.
We're multiplying by 0.4, so it's going to be a little less than half of the length. All right, how about next one? It got a little distorted on the screen. It is a square, though. So again, follow steps. What do you get? So what do I need first? Colin?
You write area equals length times width.
Yes. What do I need next? Somebody else. Mia? Close? 5 what? 5 veggie burgers times 5 veggie burgers? Yes. 5 centimeters times 5 centimeters. How about after that? What do I need? Allie?
5 centimeters times 5 centimeters equals 25 centimeters.
Doesn't equal 25 centimeters. You're close, though.
Square?
Yes. 25 centimeters squared. Okay. Now we have a circle. What's its circumference? What are my steps? What are my steps here? What do I need first? Circumference of a circle? Silence. Good look. Hey, Lucy?
The formula?
which is?
C equals pi diameter.
Yep. Oops. I guess I did area first. So area, pi r squared. Substitute in my numbers. Pi, we get 3.14. What's the radius of this circle? What's the radius of this circle? So you can,
2.5 centimeters.
yes, 2.5 centimeters. So we have 3.14 times 2.5 centimeters squared. When you're doing this on your calculator, which one do you do first? How do you do this on your calculator? There's a correct order here. Because if you do it in a different order, you'll get a different answer. You guys learned about order of operations? Yeah, what comes first?
Parentheses.
Parentheses. Okay. Actually, these aren't actual parentheses though. Then what? Exponent. You need to do the 2.5 squared first, then multiply. What do you get for an answer? Anyone got the calculator? Kira?
13.7 centimeters.
Think, did you do the power first? Did you do the squared first?
I did 3.1.
So 2.5 times 2.5 is, let's confirm here. Are you saying I'm wrong, Kira? Is that what you're trying to tell me? Let's see. 2.5 times 2.5 equals 6.25 times 3.14 equals 19.625 square centimeters. Circumference, pi d. What do you get for an answer for circumference? Somebody? Anybody? Circumference. Gabby?
C equals pi times the diameter.
Right, but what do we get for an answer? We got it? We got our substitution, Seaton?
We got
15.7 centimeters. Why not centimeters squared? What?
because it was under the edges.
Yeah, it's just the length. It's the length around the circle. We only had 1 centimeter, so it's just centimeters. Okay, now you don't have this slide. It's okay. I just want to review this with you. Because one of the things we have to do is use a map and a scale to figure out actual distances. Okay? And I know you probably have done this before, but I just want to review this stuff. So if you have a map in front of you, usually on a map there will be a scale somewhere, or maybe near the bottom or somewhere. It tells you on this map, certain distance on the map equals a certain distance in real life. There's all different scales to maps. You know, we can have 1 centimeter equals 10 kilometers, or 1 centimeter equals 1,000 kilometers. Just depends on how big the map is representing, how big of an area. Let's look at an example. So when you want to calculate the actual distance between 2 points, what you do is you measure their distance on the map using a ruler. Then you look at the scale and you multiply. Okay? The distance on the map times the map scale, that gives you the actual distance. For example, in this map, the scale is 1 centimeter is equal to 110 miles in actuality. So if I measure the distance between the Shire up here and Mount Doom in Mordor down here, okay, that distance is 8 centimeters between those two locations. Okay, if we multiply 8 centimeters times the map scale, which is a centimeter equals 110 miles, it's actually 880 miles between the Shire and Mount Doom. That's a long journey. What's that? Mount Doom? Because it's an evil place. Got the hive soaring watching you all the time and fire and all that stuff. All right, any questions about max scales? All right, you can put that away. We have the rest of today and tomorrow to work on 2 assignments which are due on Thursday.